Imagine you could only drive your car once. You buy it, you set it up to get to a location, and on your return from that location, you can no longer drive it. This will make having a car very expensive and almost impractical. But what if I told you that that's the situation with rockets? What if we told you that most of these rockets can only be used once? Welcome back to Gentle Dosage. Rockets, as exciting as they are, do not come cheap. In 2019, Jim Bridenstine, who served as the 13th administrator of the National Aeronautics and Space Administration, popularly known as NASA, stated that it will cost around $1.6 billion to purchase the rocket that will put man back on the moon. The cost will be slashed to $800 million if the rockets were purchased in bulk. This should tell you that rockets are in no way cheap, and what's more, in more cases than not, they can only be used once, and that's all. How rockets work. To fully understand why this is so, it is necessary to understand how rockets actually work. It has been established that the Earth's atmosphere gets thinner at high altitudes. This means that devices that move forward or gain altitude by pushing against any surrounding medium like air will be of no use when higher altitudes and eventually space is reached. This includes wings and propellers. This has been known since the days of the hot air balloon, but it is one thing to know the problem and another to actually find a viable solution to it. If those were not going to work, then surely gasoline and steam would. Well, not really. The challenge with combustion engines using these types of fuel is that they generate power by burning in the oxygen which is found in the Earth's atmosphere. This will fail in space and probably altitudes high enough because of the absence of oxygen. Although the early rockets were not exactly designed for space exploration, the higher they went, the more they faced these kinds of challenges. The ideas from the three influential personalities mentioned and Sir Newton were all applied in the early rockets that allowed it to overcome this challenge. The missiles were designed for war, but they had an intelligent way of dealing with this problem as they generated force without the need of a surrounding medium. But you might be wondering, aren't rockets essentially using fuel and combustion when they launch? And the answer is practically yes. How then do they burn fuel to keep going in space where oxygen levels are low or non-existent? Rockets carry a chemical called an oxidant that performs the same role as oxygen would if it were present. It enables the fuel to combust in the atmospheres where oxygen isn't present. The combustion provides the needed thrust to escape the Earth's gravitation and make it to space. Aircraft and jet engines will not work in space considering they all need air to work. Rockets, however, are a different story because of how they run. Rockets take advantage of Newton's third law of motion, which states that for every action, there is an equal reaction. The exhaust pushes out of the rocket's engine towards the ground, which becomes the action force, and the reaction force to that is the lifting of the rocket off the ground. This means that rockets have to carry large amounts of fuel and launch in stages. In recent times, most rockets launch in 2 stages. A rocket is made of 4 major parts. The first of these parts is the structural system or frame, which is basically its exterior. It is made up of strong but lightweight materials like titanium or aluminum. It employs long stringers which run from the top to bottom and are connected to hoops that run around the circumference. The skin is attached to stringers and hoops to form the basic shape of the rocket. It is further coated with thermal protection system to keep out the heat of air friction during flight. This is critical for maintaining cold temperatures for the fuel and oxidizers within. The final part of the exterior is the fins which provide stability during flight. Nothing that you see on the rocket is for aesthetics only. Everything has a role, no matter how small and pointless it may seem. Next up, we have the payload system, which is largely dependent on the mission of the rocket. The military rockets, like the V-2 mentioned earlier, contained pounds of explosives. The payload changed and was modified to launch satellites and even people when new uses were adopted for the rocket. Next is the guidance system of the rocket, which includes very sophisticated sensors, radars, onboard computers, and communication equipment to help control the rockets in their flights. Earlier rockets used small vanes in the exhaust of the nozzle to deflect thrust from the engines, whereas modern rockets rotate the nozzle. This prevents the rocket from tumbling mid-flight. The last part is probably the part that takes up the most part of the rocket. This is the propulsion system. There are two main classes, such as liquid rocket engines and solid rocket engines. The propulsion system houses the fuel, oxidizer, pumps, and nozzle of the rocket. As stated earlier, rockets launch in stages, and each stage of a rocket launch has its own set of engines and fuels. They are stacked in a shared cylindrical shell, which means they can detach when necessary. The first stage of every rocket launch gets it out of the lower Earth's atmosphere. Given the fact that the first stage of the launch is responsible for the lift of the entire rocket and its cargo or payload, it houses the biggest and most powerful engine and fuel combination. Once the first stage of the launch is successful, the rocket drops the parts responsible for it and ignites the second stage. This stage has less weight and does not have to fight through a thick atmosphere compared to the first. This means that it does not need as much power as was needed in the first stage. All fairings are let go in this phase, which refers to the pointed cap at the tip of the rocket meant to protect the payload, which might be the satellite or the people on board. Most of the parts of the rocket fall back into the Earth and are burnt up upon re-entry into the Earth's atmosphere. At this point, I'm pretty sure that the picture is becoming clearer, and you're starting to understand why rockets have not really been reusable. History: reusable launch systems. NASA did attempt to start recovering and reusing rocket parts in the 1980s with the advent of the space shuttle. The engineers modified the rockets to have parts that could easily be recovered and reused. These adjustments were mostly done to the propellants of the rocket, with the idea that they could be recovered from the sea, refurbished, and reused. This did not turn out to be as cost-effective or efficient as they would have wanted, as it was still marginally expensive to recover the propellants from the sea to reuse. The idea of building a propellant or booster that will be capable of returning to base or a specified spot was surreal and almost impossible with the technology that existed at the time. Also, rocket launches were not as often then, especially ones that will include a rocket-like shuttle they designed. Due to the cost that came with operating the shuttle, it was discontinued. NASA isn't exactly known for building its own rockets, unless its needs are not being served by the commercial market. Considering the frequency and nature of NASA's space exploration, reusable rockets are not exactly a priority. What about other space agencies? Well, the French and Russians have at one point worked together in an attempt to make a reusable rocket. This was the Ariane 5. However, the needed technology was too difficult to put together. For many of these organizations, the R&D, or research and development, needed to make this feat possible is not one that they are interested in investing in. Reusable rockets can be single-stage to orbit, as well as multiple-stage to orbit, which is more of what we have discussed so far, even with non-reusable rockets. This is because single-stage to orbit rockets are not yet viable, especially when it comes to discussions involving reusable rockets. The success and progress made with reusable rockets and launch systems have all been in the area of multiple-stage rocket systems, more specifically, two-stage systems. The history of reusable launch systems is one filled with lots of trials and errors. Studies on reusable rockets started as far back as 1958 by the United States Air Force, or USAF, and the National Advisory Committee for Aeronautics, NACA. The first product of their studies will be the shuttle from 1981. But what does the timeline for the development of reusable rockets look like? Let's find out. Wernher von Braun studied and worked on a concept for reusable rockets from 1948 to 1956. It only remained a concept, though, and was never fully actualized. The BAC Mustard was another concept that was studied and researched, yet never fully actualized. It had an interesting design, though. It featured 3 planes arranged and strapped together, which would detach and glide individually back to Earth after the first stage. The project was rather ambitious without the required funding, so it had to be axed in 1967. The shuttle came next, but then we all know how it went and how it ended. There were different versions of the shuttle, however. One of the earliest versions was the Space Shuttle Columbia, which achieved a total of 27 landings but was lost on its 28th attempt with all crew on board. The same happened with the next version, codenamed Challenger, which only achieved a total of 9 landings and was lost with all crew on its 10th attempt. Other shuttles, such as Discovery and Atlantis, landed 39 and 33 attempts respectively. Private companies like Rocket Plane Kistler and Rotary Rocket attempted to build reusable rockets to replace the shuttle, but ended up going bankrupt before they could reach their goal. Even NASA joined the train and attempted with single-stage orbiters named the X-33 and X-34. They ended up abandoning the projects due to the technology needed and the cost associated with making it practical and a reality. Many private corporations and institutions attempted to make reusable rockets possible and mainstream, but they mostly gave up due to the technology involved and their inability to fund the project. SpaceX and Blue Origin are, however, different stories. They are together the biggest private corporations as far as private rockets are concerned, especially reusable rockets. We all know their owners, Elon Musk and Jeff Bezos. If you know anything about these two billionaires, it's that when they set their minds on something, they truly go all out on it, and their space programs are no exceptions. These two institutions have been researching reusable rockets due to their goal of making space travel cheaper and available to as many as possible. It took SpaceX 14 years to make headway in its quest for a reusable rocket. It required technology that did not exist when they started. Nonetheless, they have actually been successful with building rockets with first stages that return to the Earth and land by themselves. Although they are not quite there yet, it is a great feat and makes the future a bright one. The Falcon 9, which is a SpaceX rocket, was able to recover at sea on its maiden flight. Although this was quite the feat at that time, it was successfully relaunched, which will go on record as the first successful launch of a recycled booster. It was capable of returning to its landing on the ocean platform, which potentially makes it capable of being relaunched into space. Elon Musk's remark after this was, "This is a huge day. My mind is blown." The booster originally delivered a satellite to space, after which the booster disconnected and returned to the landing pad in the Atlantic Ocean. The booster refers to the propellant or bottom part of the rocket, which houses 9 of its engines. This technology is capable of cutting down rocket costs to about 30%, and that's huge. The boosters are expected to fly 10 times with no refurbishment and 100 times with repairs and reconditioning. Blue Origin has also had similar success as SpaceX in its quest to develop reusable rockets. According to official sources, its reusable rocket, nicknamed the New Shepard, has 15 successful and consecutive missions. They have even been successful in carrying out 3 escape tests to show that the crew escape system could be activated safely in any phase of flight. These advancements might not seem so impressive until you compare them with previous launches and see how much is being saved with the investment in reusable launching systems. The Apollo, which operated from the year 1961 to 1972, cost a total of $390 million for every crew member that it carried, and the Space Shuttle, which operated from 1981 to 2011, cost around $170 million per seat. You'd have to agree that these costs are outrageously high. But what if we told you that due to the research and investments being made into reusable rockets and launch systems, the cost per seat has dropped significantly and is still dropping? The SpaceX Dragon 2, which is meant to replace the Falcon 9, is said to cost as low as $55 million per launch. Although still high, it remains significantly less than the other two. If SpaceX and Blue Origin keep succeeding in their venture to make reusable rockets, we could see this number drop significantly, especially since Elon Musk has publicly declared he intends to make space travel cheaper and is not at his goal yet. Application of reusable rockets. But where do we go after fully making rockets fully reusable? Why does it matter at all? What impact will it have on our future and the way we live our life? Let's start with transportation. Imagine a vehicle, or in this place a rocket, with a speed of 27,000 kilometers per hour, moving you from one point of the globe to another in less than an hour. You could move from London to Dubai in 27 minutes, or from Hong Kong to Singapore in 22 minutes. This will be a game changer, and we can finally say goodbye to jet lag and long 12-hour flights. Reusable rockets will make this possible, since the boosters or propellant system of the rocket can always be saved and reused for launch. If we are to go by SpaceX predictions for how long its boosters will last, we are looking at least 100 flights before having to change them. This might not be the case considering how fast technology is advancing. It might end up lasting much longer than anticipated. Actively using rockets, even on the planet Earth, will go a long way to affect and change the transportation system as we know it. If you have been watching the news lately, then you would have realized that our billionaires Richard Branson and Jeff Bezos fulfilled their boyhood dreams of going to space. Once rockets become reusable, this will become normal and affordable even for the ordinary individual. The cost of launch will be greatly reduced, which will give others the chance to actually go and experience space. Imagine attending dinner or spending your honeymoon in space. Well, it could happen. How fast is dependent on technological advancements. As stated earlier in the video, NASA's estimate for the Space Launch System, also known as the SLS, which will put a man on the moon, is likely to cost $1.6 billion. The rocket is not reusable. SpaceX is however building a rocket referred to as the Starship, which will with time cost $2 million per launch, with similar capabilities as the Space Launch System. It will literally cost a fraction of the SLS, while being reusable. Interplanetary travel and colonization will also become possible as we learn to reuse rockets. The Artemis Accords, which is an international agreement among sovereign nations for space exploration, is one that will greatly benefit from reusable rockets. There is no way the technology that sent the first man to the moon could be exclusively utilized in space exploration. Sci-fi and TV series such as The Expanse have all alluded to the fact that humans will be able to explore different parts of the solar system and build colonies. The series shows off some advanced tech where the humans end up living like the Belters, who ended up living on a ship. These ideas seem over the top, but considering how far we have gone in technology, it doesn't anymore. In fact, the ability to colonize planets and live off-world, more specifically off the Earth, might come in handy in the future considering factors like population overgrowth and the overall safety of the planet Earth. Reusable rockets, however, will be the key to unlocking and actually making this a reality. The advantages that come with making rockets reusable are quite numerous and significant. One other advantage is the fact that the launch of satellites to space will also become cheaper. This will see many satellites that are important yet might not have been launched due to the cost involved finally being launched into orbit. Research will also become a lot easier, especially ones involving rocket engines in space. We could end up seeing the engines used even for planes being modified and made more efficient due to the advancements being made with rockets. Reusable rockets, as insignificant as they might sound, once fully established, will surely change everything. Imagine having the technology to finally travel to Mars and back in the same rocket, or finally being able to colonize the planet. Bear in mind that before we can even think of colonizing and terraforming any planet, we must first be capable of reaching there. This is what reusable rockets will ultimately be offering to us. Applying the technology on the Earth, we will be able to move individuals from one point of the planet to another in less than an hour. Think of the implications. The fact that we will be saving a lot of money due to these reusable rockets means that we will be launching more of them, studying more, and slowly mastering travel. Certainly, this will make interplanetary travel possible much sooner. Do you have any other thoughts on how reusable rockets could change our future? Share with us in the comments below.